Number 3. The density of copper is 8.89 grams per cubic centimeter and the resistivity is 1.724 micro-ohm-cm. Determine length in meters and the resistance of 12 kilogram copper, the cross-section of which is 2.09 square meter. Okay, so let's evaluate the problem. We are tasked to determine the length and the resistance. We all know that length and resistance is directly proportional. If we recall our formula for our resistance is equal to resistivity, length all over the cross-sectional area. If we try to check our given, do we have the value for our length? Negative, that is unknown. How about for resistance? That is also unknown. How about for our resistivity? It's given and the cross-sectional area is given. So let's deal our length first. If we recall the formula for our weight density, since weight density is given in the problem, so if we recall our formula for weight density is equal to total weight all over the volume. Now, do we have the value for weight density? Yes. Do we have a value for our total weight? Yes, that is 12 kilogram. That is 12 kilogram of copper. So we can determine our volume. Solving for your volume is equal to the total weight over the weight density, which is equal to 12 kilogram all over 8.89 grams per cubic centimeter. Okay, let's cancel out units. So grams, kilograms, this is thousand, we cancel grams, so the remaining unit is in cubic centimeter, which is the unit for your volume. So finally, solving for your volume, so you multiply here 10 raised to 3 for your kilo. Okay, finally, the value of your volume is 12,000. This is 1,349.831271 cubic centimeter. That is the value of your volume. Again, we already have our volume. Can we determine the length? Do we have a cross-sectional area? Yes. If we recall our cross-sectional area formula for our cylinder, we have a cross-sectional area is equal to 1/4 pi over d squared. But the cross-sectional area is already given. If you see, the cross-sectional area is already given. Okay, if we recall how to determine our volume, this is length. So in order to get the volume of the cylinder, we multiply the cross-sectional area times length to have the volume of the cylinder. We can do this since we have a copper. It's not defined if it is a conductor, but looking at the length, looking at the parameters, the resistivity, it shows that the problem is describing a conductor. So we can use a cylindrical shape one. Say, do we have a value for our, let's check our availability of data. Do we have a value for our volume? Yes, we just recently solved it. How about for cross-sectional area? Yes, it is given the problem. So we can determine the length now. Okay, solving for your length. So therefore, our length here is equal to the volume all over the cross-sectional area. So your volume is, we already solved the volume, 349.831271 cubic centimeter. How about for our cross-sectional area? We have 2.09 square millimeter. Okay, so all we need is what? We convert in order to eliminate the units. So we need to convert the cross-sectional area to centimeter. In every 1 millimeter, we have zero point 0.1 centimeter. Remember, we are here in square. So we give it a power also. Okay, so we need to cancel out common units. So cancel out square millimeter, and the remaining unit here is square centimeter. So what will happen? So if we have square centimeter here in the denominator with cubic centimeter, what we cancel out the square centimeter, and the remaining unit at the numerator will become centimeter alone. Okay, finally, your length is equal to 64,585.22828 centimeter. But wait, the length in meters. So we are tasked to determine the length in meters. So we only need to convert our centimeter to meter, which we have in every 100 centimeter, we have 1 meter. So finally, our length is equal to 645.8522828 meters. Okay, we cancel out centimeter here, the remaining unit is in meters. So this is your length, 645.8522828 meters. So we are done with our first unknown. We determined the length in meters. How about for resistance? Okay, so in our resistance, we determined already the length. We have the resistivity and the cross-sectional area. Um, we just solved it right away. Okay, so for your resistance, resistivity length over the cross-sectional area, which is given. What is the value of your resistivity? 1.724 micro-ohm-centimeter. How about for your length? That is, since it is in centimeter, we use the centimeter data. Okay, so that is 64,585.222828 centimeter. How about for our cross-sectional area? Our cross-sectional area is 2.09 square millimeter. So what do we do? Oh, we simply convert the denominator side, the millimeter. So in every millimeter, there is zero point 0.1 centimeter. Of course, our unit here in squared, we square our denominator also. So let's check and eliminate common units. So square millimeter, this will become square, it will be cancelled out. The remaining unit here is in square centimeter. How about above? So the remaining unit here is micro-ohm, micro-ohm centimeter times centimeter, that is square centimeter. So we can finally cancel the square centimeter at denominator and then square centimeter in the numerator. So solving for your R, finally your R is Your R is 5.327508783 ohms. So that is the value of your resistance.